You know that feeling?
Yeah.
That specific kind of panic.
Oh, yeah.
It's 11:00 p.m.
Yeah.
The house is totally quiet. You've got a video edit due, say, 9:00 a.m. sharp.
The deadline.
Right. And the pacing is tight. The color grade looks good. The audio is mixed. But then you hit a gap. You're missing the hero shot.
Yeah.
And not just a small B-roll clip, but the one transition that makes the whole thing work.
The linchpin.
So you check the stock libraries, nothing. You check your hard drive, still nothing. And suddenly you're calculating if you can hire a helicopter crew at midnight.
Which, spoiler alert, you can't. That is usually the moment you just compromise. You slap in something mediocre and hope the client doesn't notice.
Exactly.
But we are not doing that today. We're looking at option 4.
Option number 4. Welcome back to the deep dive.
Today we're looking at, well, the state of AI filmmaking in early 2026.
Yeah.
We've got a guide here by Max Ann titled How to Generate Pro-Level B-Roll Footage on Demand in 2026. And what stands out to me right away is the shift in tone.
We're not talking about those glitchy, nightmare fuel videos from a couple of years ago.
Yeah.
We are talking about precision.
We really are. We're moving past the novelty phase, as this isn't about typing cat riding a skateboard anymore. This is about directing.
Directing.
Yeah, the guide focuses on using the heavy hitters Veo 3.1, Sora 2, Kling 2.6 to bypass stock footage entirely. But the core argument, and I think this is the part that changes the game, is you have to stop guessing and start directing.
Directing the algorithm. I like the sound of that, but I want to unpack what it actually means because it can sound a bit buzzwordy.
For sure.
So here's the roadmap. First, we need to understand this strategy shift, this thing called image-to-video orchestration. Then we're going to dissect the director's blueprint, the actual anatomy of a prompt that works. We've got 3 case studies that are frankly mind-blowing. A train in the Alps, a garden metaphor, and a zoom from space.
Yeah, that last one is something else.
And finally, we'll look at the personalities of these different AI models.
It's a dense agenda, but a fun one.
Let's start with the strategy. The source material makes a pretty bold claim right off the bat. It says the old way of doing this, text to video, is fundamentally broken.
It is. It's broken because it relies on the machine guessing.
Guessing.
If you open Sora or Veo and type cinematic shot of a woman walking down a street, you're leaving a million variables just completely undefined. The lighting, the lens choice, the texture of the pavement, the era of the architecture.
Right.
The AI has to fill in those blanks. And usually, it hallucinates.
Okay, so when you say hallucinates in this context, what are we actually seeing on screen?
We're seeing the melting watch effect, the AI starts guessing, and suddenly the woman has 6 fingers, or the buildings in the background start to warp like they're made of liquid. It's like a dream where you look at a clock and the numbers just slide off. The AI creates a vibe, but it fails at physics.
Right, it feels like a slot machine. You pull the lever, you get garbage. You pull it again, maybe you get something usable.
Yep. Exactly. And that is why the professional workflow of 2026 is image-to-video orchestration. It creates a firewall between the composition and the movement.
Walk me through the mechanics of that.
It's a 2-stage process. You never ask the video model to create the world. You ask an image model to create the world first.
Okay.
Stage 1 is generating a high-fidelity starting frame.
Okay.
The guide is very specific here. It recommends a tool called Nano Banana Pro.
Nano Banana Pro.
I know, the names in this industry are getting a little ridiculous, but under the hood, it's running Google's Gemini 2.5 or the 3 Flash model.
And there's a reason for using that instead of, say, Mid-Journey for this step.
There is. It comes down to character consistency and resolution. You need to lock in a 4K image with 300 DPI clarity.
Got it.
Gemini has shown this incredible ability to follow complex spatial instructions without adding artistic flair you didn't ask for. You want a blueprint, not a painting.
Okay, so you've got this perfect static 4K image.
Yeah.
Stage 2.
Then, and only then, do you feed that image into Veo or Kling to animate it. You are essentially telling the video AI, look at this picture, don't change the lighting, don't change the face, just make the wind blow.
You know, I have to admit, I still wrestle with this myself.
Yeah.
With prompt drift, as they
Yeah.
call it. My early attempts trying to do it all in one go. Well, they looked less like movies and more like those hallucinations we were talking about.
Melting clouds.
The melting clocks, exactly. So this 2-stage process, it sounds like it takes longer to set up, but maybe saves hours of frustration.
That's the idea. You would think it's doubling the work, but think about the slot machine problem. You might spend 2 hours re-rolling to get one good shot. With this, you spend 15 minutes getting the image right, and the video works on the first or second try.
It's measure twice, cut once.
Precisely.
So just to make sure I fully grasp the mechanism here, why is generating the image before the video the critical unlock?
It locks in the composition and resolution first. It just bypasses the video AI's tendency to hallucinate low-quality details when it's trying to calculate motion and pixels at the same time.
You're reducing the cognitive load on the model. It doesn't have to invent the world and move it at the same time.
Exactly.
Okay, let's move to the director's blueprint. The source says AI responds to structure, not vibes.
This is the biggest mistake people make. They use words like cool, epic, or emotional. The AI has no idea what emotional looks like in pixels.
Right.
So Max-Ann outlines a 5-part structure that is mandatory if you want pro results.
Let's run through them.
Number 1, camera specification. You have to tell it the angle and distance. Number 2 is visual composition, the subject and environment. That's the easy part.
Right, a dog in a park.
But then you have number 3, technical details. This is where you separate the pros from the amateurs: resolution, lens style, depth of field. Number 4 is motion description, what moves. And number 5, mood and atmosphere.
I want to deep dive on number 3, the technical details. The guide mentions specific hardware, like actually naming the camera, shot on Sony Venice. Does the AI actually know what a Sony Venice is?
Oh, it absolutely knows. You have to remember, these models were trained on the internet. They've analyzed millions of frames tagged with Sony Venice or Ari Alexa.
So it's not just placebo tech.
Not at all. When you type Sony Venice, you are triggering a specific set of weights in the neural network. You're telling it, I want high dynamic range. I want a specific color science where the highlights roll off smoothly rather than clipping into pure white.
That is fascinating. It's like code switching. You're speaking the language of the training data.
Exactly. If you just say cinematic, the AI gives you this generic, high-contrast digital look, basically a Videocom cutscene. But if you specify the camera, you get texture.
So what happens if I have a great prompt, a train in the mountains, but I leave out those camera specs?
Without the camera or lens specs, the AI defaults to a flat digital look. It feels like generic stock video instead of a rich cinematic film.
Which brings us to the fun part, the case studies. I want to see this theory in action. Let's start with that classic travel shot, the Swiss Alps train.
The peak wanderlust shot.
We've all seen it. Red train, stone viaduct, snow-capped mountains. But the prompt here is so specific about the glass.
It is. The prompt calls for a Sony Venice with an RE Signature Prime 24mm lens.
Why that specific lens? Why 24mm?
It's about the language of cinema. A 24mm lens is wide, but it's not a fisheye. It captures scale. It tells the AI we want the mountains to feel massive and the train to feel small. But more importantly, naming the Signature Prime lens tells the AI to keep the image sharp corner to corner, but with a slight organic softness so it doesn't look like CGI.
And because you use the image-to-video workflow, you're not just getting a red blur. You get the texture of the stone on the bridge, the light hitting the paint.
Right. And for the motion, the prompt is simple. Camera follows the train smoothly. Steady aerial tracking shot. You don't need to overcomplicate the movement if the image is perfect.
Okay, let's pivot to the second case study, because this one feels very different emotionally, the growth metaphor.
Right. This is for when you need to illustrate patience or progress. The visual is weathered hands pouring water and a seedling emerging from the soil.
It feels much more intimate, and the hardware choice changes completely.
Drastically. For this one, the guide recommends an ARI Alexa 35 with a 50mm lens.
Why the change to 50mm?
The 50mm lens is often called the nifty 50 because it roughly mimics the human eye's perspective. It feels natural, it feels honest. But the key here is the aperture. With a 50mm, you get bokeh.
Bokeh. That's the aesthetic blur in the background, right?
Correct. You want the background, the garden, the fence to melt away into soft shapes. It isolates the subject. If you use the wide-angle lens from the train shot here, it would just look weird and distorted. The 50mm makes it feel like a documentary.
There's a detail in the source here that I found really interesting. It emphasizes weathered hands and a watering can with aged patina. Why is that texture so important?
Because perfection is the enemy of realism in AI. If you ask for hands, the AI gives you smooth, plastic, mannequin hands. By asking for weathered or aged patina, you're forcing the AI to render imperfections, scratches, wrinkles, dirt.
Huh?
That grit tricks our brain into thinking, oh, this is real footage.
It's the uncanny valley concept. We reject things that are too perfect.
Exactly. But, and this is a big but, there is a warning here regarding hands.
Oh, right. AI and hands have a a terrible relationship.
The finger glitch problem. The guide advises keeping the hand movement minimal. The prompt says, hands stay mostly still, just tilt the watering can. If you ask for complex finger movements, the AI is likely to morph the fingers into spaghetti.
So you have to design the shot around the limitations of the tech.
You do. Keep it simple is the rule for motion.
No, we have to talk about the third case study. This is the ambitious one, the impossible zoom.
This one blew my mind.
The shot starts from a 3D relief map in low Earth orbit, looking down at the U.S. Then it zooms all the way down to Lake Michigan and ends in downtown Chicago.
Just think about the logistics of filming that for real. You'd need satellite imagery, high-altitude drone footage, helicopter footage, a camera on a crane. It is a $50,000 shot, minimum.
The kind of thing you see in a Marvel movie.
And here, it's a prompt, but a very complex one. It requires prompt logic. You can't just say, zoom in on Chicago from space. The AI will get lost.
Oh, how do you do it?
You describe the layers, hyper-realistic, low Earth orbit at dusk. You describe the lighting changes, the golden city lights, and the deep blue atmospheric haze. You're essentially guiding the AI through the layers of the atmosphere.
But the source mentions this one is hard to pull off. It usually fails on the first try.
Maxan is very honest about that, which I appreciate. You might get weird light flashes. The transition from space to atmosphere might warp. The buildings might look like they are vibrating.
So what's the recommended fix if the AI glitches on that transition?
You iterate. You can either split the shot into stages, generate the space part, then the descent, then the city, and stitch them together. Or you generate multiple versions, pick the best 80% of each, and trim the bad parts.
So it's less about one perfect generation and more about gathering raw material to sculpt. You're still an editor.
Exactly. You're still a director. The AI is just the camera.
I want to shift gears slightly to the tools themselves. We've mentioned Veo, Sora, Kling. The guide suggests they have distinct personalities.
They really do. Just like you choose a different cinematographer for an action movie versus a period drama, you choose your model based on the shot.
Let's break them down. Start with Google Veo 3.1.
Veo is the grounded realist. It's the benchmark for photorealism and lighting physics.
Yeah.
If you're doing nature shots, architecture, or that director's blueprint, environmental stuff where shadows need to fall correctly, Veo is the go-to.
Okay. What about OpenAI's Sora 2?
Sora is the artist. Best for narrative, surrealism, connecting the dots visually. If you have a shot that requires a bit of dream logic like one object morphing into another, Sora shines there. It's less rigid about physics.
And Kling 2.6.
Kling is the action star.
Yeah.
It's the leader for fast motion. If you're making a car chase or something with rapid movement, Veo might get blurry, but Kling holds it together. It keeps the edges sharp.
The guide also has a hardware cheat sheet, which I think is worth listing out.
Definitely. This is the secret sauce. So if you're taking notes, write this down.
Okay.
For a wide shot, your prompt should say Sony Venice plus 24mm lens. For a portrait, ARI Alexa 35 plus a Cooke S4 50mm lens. For an intimate close-up, use a Red Komodo plus an 85mm lens. And for a documentary look, Canon C300 plus a 35mm lens.
That's incredibly specific. Cooke S4 lens. I love that the AI knows what that glass looks like.
It does. A Cooke lens has what cinematographers call the Cooke look. It's warm, forgiving on skin tones, a vintage feel. The AI replicates that warmth. If you ask for a Zeiss lens, it would give you something cooler and sharper.
So just to clarify on the model choice, why does Veo get the nod for those specific environmental shots in the director's blueprint over the others?
Veo excels at environmental coherence and lighting physics. It's just less likely to produce that dream logic or weird artifacts in scenes that are supposed to look like the real world.
It keeps you grounded.
Exactly.
We are back. We have covered the strategy, the blueprint, the case studies, and the tools. I want to try to synthesize this into a big idea.
Let's do it.
It seems to me that the core philosophy here, the unfair advantage that Maxan talks about, isn't actually the tool itself. Everyone has access to Veo or Kling.
Right. The tool is democratized.
The advantage is the move from describing a scene to directing it.
That is it. That is the whole ballgame.
It is the difference between saying, I want a burger, and telling the chef exactly how you want the meat ground, the bun toasted, and the sauce layered.
And that's why the workflow is so rigid. Image first using Nano Banana Pro, I still can't believe I'm saying that name seriously, to lock in the pixels. Then motion using Veo or Kling. And always use specific camera references to force the AI out of generic mode.
It's interesting. Usually we think of AI as this thing that gives us infinite freedom. But here, the argument is that freedom leads to mediocrity. Constraints lead to excellence.
AI video tools close the gap between imagination and execution, but they are only as good as the structure you provide. That's the quote from the guy that sticks with me.
So for the listener, the person who maybe has a presentation next week or just wants to play around, what is the immediate next step?
I would encourage you to try one impossible shot this week. Don't just make a cat video. Open up Gemini, type in Sony Vanessa, try the growth metaphor.
Write down the prompt. Camera, composition, tech details, motion, mood.
Exactly. Save that cheat sheet. See if you can create something that looks like it costs $10,000 while sitting on your couch, just to see if you can.
I love that. We're entering an era where budget is no longer a barrier to visual storytelling. The only barrier left is the clarity of your vision. Can you see it clearly enough to describe it in the language the machine understands?
That is the question.
Thank you for diving deep with us today. Go direct some algorithms.
See you next time.
Take care.